In this video, we will prove a theorem that states that the only idempotent element in a group G is the identity element. Now coming towards its proof, let X belong to G be an idempotent element then by definition of idempotent element we can write x square is equal to x. Since in this theorem we have to prove that the only idempotent element in a group G is the identity element, so we shall show that x is equal to E. And we can write x square as x multiplied by x equal to x. Since x belong to G and G is a group, which implies that x inverse also belong to G, because in a group inverse of every element also exists. So if x is an element of G, then x inverse is also an element of G. That is, if x belong to G, it implies that x inverse also belong to G. Let's name this equation as equation A and multiply x inverse on both sides of equation A. We get x inverse multiplied by x into x equal to x inverse multiplied by x. By associative law, since G is a group, so associative law also holds. We can write this equation as x inverse into x equal to, and an element multiplied by its inverse is equal to identity. So we can replace this by E, that is identity, and again an element multiplied by its inverse is equal to identity. So we will replace x inverse into x by E. E multiplied by x is equal to E, which implies that any element multiplied by identity is the element itself. So E multiplied by x is equal to x. So we get x equal to E, which is the required proof.